So what you are going to do virtually this week, you're going to do titration. Now, before you watch the video on titration, I wanted to quickly go over the concept of what is titration and why you have to care about it. So titration is a technique to figure out how much acid or base you have. So titration is a technique to figure out how much acid and base you have. Now, why do you have to care about that? So I'm going to give you one example why you would want to do titration. Over-the-counter supplement. Have you guys ever taken vitamin C, over-the-counter vitamin C supplement? You probably have, right? Or you know someone who takes over-the-counter supplements all the time. Vitamin C, vitamin D, vitamin B. Especially right now, we really want to take our vitamin C to make sure we stay healthy. So if you take these over-the-counter supplement, I want to look at vitamin C here. And vitamin C is ascorbic acid. Vitamin C is ascorbic acid. Over here, it says that each tablet has 500 milligrams of vitamin C in it. So each tablet is going to have 500 milligrams of vitamin C inside it. Now, vitamin C is ascorbic acid. Now, here's the question for you. How do you know that each tablet actually have 500 milligrams of vitamin C and you're getting your money worth? Well, to figure that out, you can do acid-base titration, because acid-base titration is a way to figure out how much acid or base you have. And vitamin C is ascorbic acid, so I can do an acid-base titration to figure out how much acid I have in each tablet. Okay, so this is why you have to know acid-base titration is a useful technique. Now, I want to go really quickly, go over a simple titration on the board with you. So, acid-base titration, what I need an acid and I need a base. Let's say over here, I'm going to put sodium hydroxide as my base, and then over here, I'm going to put an acid. I'm going to put hydrochloric acid in here. So I have my base and I have my acid. Now, the other thing that you need, and you're going to watch the video and you're going to see that, you're going to have your acid, you're going to have your base, and you also need to add an indicator. The indicator we're going to add in lab, we're going to add phenolphthalein. I'm not even going to try to spell that one out. So you're going to add an indicator. Now, what is an indicator? And I'm going to talk about this more in a second, but indicator changes color. Basically, it changes color when there is a pH change. So when there's a pH change, the color is going to change. So far, so good? Okay. Now, here is the concept behind this. So right now, I have my hydrochloric acid, I have my sodium hydroxide, and I have my indicator. It's really crucial that you have an indicator in there. Otherwise, there is going to be no color change, and you will never know when to stop. I'm gonna start adding sodium hydroxide to hydrochloric acid. I'm gonna keep adding. I'm gonna keep adding. I'm gonna keep adding. Nothing may happen. I want to keep adding. I want to keep adding. At the beginning, the hydrochloric acid is going to be clear. I want to keep adding. I want to keep adding. I want to keep adding sodium hydroxide. And you might get bored, but stay with it. You're going to keep adding, keep adding, keep adding, and then bam, what's going to happen is going to turn pink. And it has to turn pink and stay pink. That's really crucial, because sometimes you're adding a base, you add, and you see a little pink, but if you shake it around, it goes away. That means you're getting close, but you're not there yet. So it has to turn pink, and it also has to stay. Okay. Once it turns pink, then you're done. You stop adding. Now, what does pink mean? What does this pink color mean? What does it mean? Why did it go from clear to pink? So let's talk about that. The concept behind it. Why did this turn pink? And what does it mean when it turns pink? I'm going to simplify this for you to make sure that you understand the concept. So Again, when you are doing acid base, you're gonna have a burette. And you're gonna see that in the video. You're gonna have a burette and you're gonna have sodium hydroxide in a burette. And then down here, I'm gonna have my acid. In this problem, I'm using hydrochloric acid. In your lab, you are going to have vinegar, which has acetic acid. Okay? Now remember, sodium hydroxide, if you add sodium hydroxide to water, what happens? It breaks up into sodium plus and OH minus. Now, what makes something to be a base is OH minus. This is what makes something to be a base. When you have OH minus, you are a base. So this is a part that really matters. The sodium hydroxide, the hydroxide part, is what makes it to be a basic compound. So what I have going on here, I have a bunch of OH minus in that burette. Okay, now what do I have down here? Now remember, hydrochloric acid is a strong acid. In water, it would completely break up into H plus and Cl minus. Now tell me, I know I can't hear you, tell me still, what makes hydrochloric acid to be an acid? What makes this to be an acid is the H plus. This is what makes it to be an acid, the H plus. Okay, now let's do our acid-base titration. So then what that means is I'm going to have a bunch of H pluses in here, because H plus is what makes something to be an acid and OH minus makes it to be a base. Now what I want you to remember, I have the indicator in here as well. What I want you to remember is that you don't know how much acid you have. That's the whole point of titration, to figure out how much acid or base you have. So you don't know how much acid you have in here. Okay, I'm going to start adding. I'm going to add NaOH. What's going to happen? What's going to happen is that the OH is going to go down here and it's going to react with the H plus. Now tell me, if the OH minus goes down here and finds an H plus, what are they going to form? OH minus plus H plus forms? Yes. H2O forms water, so it's going to neutralize it out. I'm going to add another OH, is going to go down here, is going to react with H plus, is going to neutralize it out. I'm going to add another OH, is going to go down here, is going to react with H plus, is going to neutralize it out. So far so good. That's why we're still clear. Nothing's really happening. Now I'm going to add another OH. Now the OH is going to come down here. Oh no! There is no more H plus to react with. There is no more H plus to neutralize the OH out. So now what's going to happen? This is going to turn pink. Because you know what we said what an indicator is? Indicator changes color when there is a pH change. So this was acidic, it was a clear solution. I keep adding the base. The base would react with the H plus, forms water, neutralize it out, and then once you add OH and there is no more H plus to react with, now I only have OH in the solution, is going to be basic now, is going to change color, because indicator changes color when there's a pH change. So the OH here has no H plus, and that's where the end point. So when the color changes, we call it the end point. You're going to see the color change going on. So this is the concept of what's going on. Now in the next video, I want to do a couple of practice problems for you so that you know how to do a calculation. But before you watch the video, keep in mind, you're going to have a burette, you're going to have a sodium hydroxide in a burette. Your acid is going to be vinegar. Now your acid is going to be a vinegar. So vinegar, that's your salad dressing, right? So we actually use a vinegar that we bought from Safeway to do this acid-base titration. Because what makes vinegar to have that sour taste is the acidic acid in the vinegar that is responsible for that. So what you're going to do in that lab, you're going to figure out how much acidic acid is going to be in your vinegar sample. So the acid here, the base over there, and you're going to do a titration. Okay, nice job. So next time,